Welcome to my math class. I am Mohammed Ali, online maths teacher. Today we try to understand one question from Cambridge International ASN level Mathematics, Probability and Statistics 2 course book, chapter 1, Hypothesis Test. We try to understand this example, work example 1.1. Experience has shown that drivers on a Formula One racetrack simulator crash 40% of the time. This is the 40% of the time. Zender decides to run a simulator training program. You want to start a simulator training program to reduce. That means 40% you want to reduce it. You want to raise it. The number of crashes. Evaluate the effectiveness of the training program. Zender allows 20 drivers one by one. Here n equals to 20 to use the simulator. Zender counts how many of the driver crash. 4 driver crash. That means after training program, he found that 4 drivers crash. Test the effectiveness of Zender's simulation training program at the 5% level of significance. One thing we know that after calculation, if we get this result less than 5%, we can reject the null hypothesis. But if it is greater than 5%, we can accept the null hypothesis. Okay. Now, let X be the number of drivers that crash. Then X, this is binomial expansion. Why binomial expansion? Because here number of drivers is 20 and probability is 40%. This means 0.4. One thing, and null hypothesis is not equals to P equals to 0.4. And as we want to reduce, that probability will be, we want the reduce of crash, that means P less than 0.4. This information is very important for us. We try to understand these things. Define a random variable and its parameter. Here, our parameter n equals to 20, x is random variable, and probability equals to 0.4. The null hypothesis is the current value of P. Our current value of P, that means probability is 40%. 40% means 40 divided by 100, that means 0.4. This is the probability. So null hypothesis is the current value of P. That's why our probability is 0.4. The alternative hypothesis is training is effective. So P is smaller than 0.4. If the training is effective, we assume that training is effective. That means the probability of crash will be less. That's why alternative hypothesis P less than 0.4. The null hypothesis H0 is the assumption that there is no difference between the usual outcome. Our usual outcome is 40%. So H0 will be 40%, that means 0.4. And what you are testing. The usual outcome is crashing 40% of the time, that is P equals to 0.4. The alternative hypothesis H1 is P less than 0.4. Since Zender's training program aims to reduce, his training program aims to reduce the probability of crashes. Okay. Now, for driver crash, we calculate the test statistics. What is test statistics? Test statistics is the calculated probability using sample data. Our sample data is 20 and 0.4 in a hypothesis test. So the reason is probability of X less than equals to 4 because 4 drivers crash and we want to reduce these things. The probability of X less than equals to 4 equals to 20. It is 20, like 0 means 20C0 or 20C0, 0.4 to the power 0 and 0.6 to the power 20. Why 0.6? This is actually binomial expansion. We know that, like this is n, like here, if it is 1, this is the probability, like 0.4 is the probability that power is 1. And if 0.4 is probability, that means so p is 0.4 and q equals to 1 minus p, that means 1 minus 0.4, so it will be 0.6 to the power. If it is like 20, it is 20 minus 1, that means 19, in this way. So 20 C1, 0.4 to the power 1, 0.6 to the power 19, plus 20 C2, 0.4 to the power 2, 0.6 to the power 18, plus 20 C3, 0.4 to the power 3, multiplies 0.6 to the power 17, plus 20 C4, 0.4 to the power 4, multiplies 0.6 to the power 16. After calculation, we will get 0.050952. That means 5.10%. So it is greater than, so px less than equals to 4 is greater than 5%. 5.1% is greater than 5%. So 4 is not critical value, because it is, we can't reject this thing. So 4 is not critical value, therefore accept H naught. There is insufficient evidence at the 5% significance level to suggest that the proportion of drivers crashing their simulator has decreased. Okay, so compare the calculated probability with the percentage significance level. Here our significance level is 5%. Decide to accept or reject. As it is greater than 5%, we definitely accept the null hypothesis to comment in contest. In this case, calculate probability must be less than the percentage significance level to say that sufficient evidence to reject the null hypothesis. But here, our probability will get greater than 5%. So there is insufficient evidence to, at the 5% significance level, to suggest that the proportion of drivers crashing their simulator has decreased. I think everybody understand this maths. So at first read the question properly and try to do this maths. Thank you everybody for watching. Thank you all.